what is this neutral axis? Okay, so the neutral axis. So at the neutral axis, okay, the normal stress or the stress x, okay, the stress in the x direction will be equal to 0. Okay, this will be equal to 0. Okay, now let's look at this now. So we want to call 2 points now. Okay, I'm going to call 2 points. So there's a point over here. So where I am looking at is we are going to look at exactly at point C. Okay, we are going to focus on point C. Why we are focusing on point C? Because we just declare what? Sorry, point B, not point C. I do apologize. So point B, because we did declare that failure, right? We did declare that failure will occur at point where? At point B. Okay, so we're just going to look at point B. No point calculating point A. No point calculating point C, because failure will not occur there. Okay, so rule number 1 regarding structural analysis is you will calculate where failure will occur. Okay, I think, yeah, that was a question in the term test. Yes or no? You have to test, right? Where is the highest shearing stress? Right? We don't know. So one way to know is through testing. This we know because we know failure will occur at the center. Okay, we are aware that failure will occur at the center. Okay, so now looking at point B, so point B is a chain line now. Okay, so this is point B. Wait. Right, and point B, at point B, I'll write point B down here. Right, at point B, we are going to call 2 points. One point is called alpha, and the other point is called gamma. Okay, one is a alpha point, one. So what you see is alpha is above the neutral axis, gamma is below the neutral axis. Okay, question: can anyone tell me is if the neutral axis has 0 stress, will gamma be in tension or in compression? Anyone, please? Anyone? Will gamma be in tension or compression?
Tension.
Gamma will be tension.
Gamma will be in tension, right? How about alpha?
Compression.
Compression. Well done. So gamma will be under tension. Okay. Alpha will be under what? Compression. Okay. And why this is because if you look at if you look at this line that I'm going to highlight now, okay, the circumference, right? The circumference is smaller than the neutral axis. Right? The circumference is smaller than neutral axis. So for the circumference to be smaller than neutral axis, it has to be under what? Compression. Okay. And where you see where gamma is, which I'm going to highlight now, the circumference is greater than the neutral axis, so it is in tension. Okay. Now, so there's one thing that I'm going to define for you now. Okay. So for this case, how the structure is bent, okay, how the structure is bent this way, right? You have moments. So the moment is in this direction, and the moment is in this direction, right? So moment is rotating. That's why your structure is deformed in that orientation. Okay. So now, based on what we see over there, there is a point known as center of curvature. And this center of curvature, right, will dictate whether y is positive or y is negative. Okay. So for this case, the center of curvature is over here. So this is known as center of curvature. Okay. That's known as center of curvature. So at any point from the neutral axis, I repeat again, at any point from the neutral axis in this direction, right, y is what? positive. Okay? So at any point, it is moving away from the neutral axis. Y is what? Negative. Remember I told you y is a what? Is a vector. So now you ask me, okay, so what? All right, so what? So if you look at now, okay, we're going to form the equation. If we look at the normal stress in the x direction, right, for point alpha, right, for point alpha, and we know that y is equal to what? Positive or negative? Anyone? It's going to be equal to
Positive.
positive. Thank you. It's going to be positive. So in this context, we have stress x at point alpha is equal to minus mz over izz multiplied by positive y. So the outcome of this is you have this equation is equal to minus mz over izz multiplied by y. So we know that the stress in the x direction for alpha point is in what? Compression. Okay. Now, if we now look at stress x at point gamma, right? For this case, at point gamma is pointing away from the what? From the center of curvature, right? It's pointing away from the center of curvature. So stress x gamma is equal to y is equal to what? Negative. So if we use the standard formula, okay, where we have stress x gamma, so this will be equal to minus mz over izz, right? And then this will be equal to minus y, right? Because it is going away from the center of curvature. So when this happens, what we have over here is mz over izz multiplied by y. This is in what? Tensor. Okay, we have to get this concept really clear. Okay, why is it mathematically, what does it means? Okay, physically we understand. I already explained to you physically. Okay, physically, because of the center of curvature at alpha is sorry, the circumference for alpha is smaller, so compared to the neutral axis, so it's in compression. So we know physically what is happening. Mathematically, I'll show you what is going on also. Okay, so one thing to observe is this. Okay, so what we have over here is we have moment in the z direction. Okay, so what we can see over here, okay, is a trend. Okay, it's a trend. So we realize that based on the moment arrow, what do I mean by moment vector? Sorry, based on the moment vector over here, right? Based on the moment vector, what we see is the head of the moment vector is always pointing towards what? Compression. I repeat again, the head of the moment vector is always compression. The tail end of the moment vector is always in tensor. Okay. I want you to remember this better than physically what is going on, rather than just putting into the formula. Okay, if you want to put in a formula, fine. Okay, but as engineers like you guys, you have to physically see what is going on. Okay, sometimes plugging everything into a formula is like putting everything in a black box, and if we are not strong in vectors, okay, the positive and negative will go crazy. Okay, or if there's a 2D loading, okay, so later on we're going to do loading both in the y and in the z direction. Okay, it's important that you know which is compression, which is tension physically. Okay, now, so what I have drawn down here, I'll write down. So the head end of the moment vector, right, the head end of the moment vector is always in compression. Okay, so this is what I call the head, right? So this is the head end, and over here, this is what we call the tail end. Okay, or you can remember tail is tension, head is what? Compression. Okay, so the tail end, okay, of the moment vector is under tensor. Okay, right. Now I'm going to give you another situation. Okay, I'm going to give you another situation. What if now, okay, so I'm going to draw our transformation. Okay, I'm going to draw a transformation. So this is our x, and this is a y. Now, what if now, okay, the deformation is this way now. Right? The deformation is this way. Okay, so things are still the same. I mean, I'm going to label not the same, but I'm going to label the same thing. So this is my point B, right? As usual, the top part is still my alpha, the bottom part is still my gamma, and then at a certain distance, okay, somewhere around here, this is known as my neutral axis. Okay, this is my neutral axis. So for this case, y positive is where? Anyone? Up or down? I want you all to compare. So Microsoft is always doing this. Anyone, please? Oi, sorry, it crashed. My bad. It's coming back. Okay, it's coming back. It's coming back. Don't worry. New window. I'm gonna bring back up for you guys to see over here. Yep. Okay. So you can see clear. Okay. So where can someone tell me where is y positive now? Anyone, please? Thank you. Hello.
Comma.
Now, yeah, Lisa. Yep. You are right. Okay. So now y positive is coming down. Oi. It's my side crashing. Okay, so don't worry about it. So I'm going to do this again. I've opened my window, so more wind will come in, but the computer is just too hot. Maybe I will lower my screen resolution. Okay, you can still hear me, yes? Okay, so we realize now that at this direction coming down, this will be our y positive. This will be our y negative. Why is that? Y positive is coming down? Because now over here, right, this is our center of curvature. Okay, that is our center of curvature. So when that's the case, right, so for this case, we are going to write out a new set of formulas or a new set of analysis on what we see. So now for this diagram over here, the one below, right, so we now know that stress X at alpha, right, for stress X at alpha, Y is now equal to what? Negative, right? So in this context, we know that stress X in point alpha is equal to minus MZ over IZZ. Now multiplied by Y is negative, so this is equal to positive MZ over IZZ multiplied by Y. Okay, so likewise, if we look at stress X for point gamma, right? So Y now is equal to what? Positive. Okay, so stress X of gamma